Hello everyone, very good evening to all of you. Welcome to PyNet Labs. So here my name is Jatin and I'll be your trainer for this webinar. So as we have planned for this interesting webinar. So in this webinar, it is all about your IPv6. So today we are going to learn about a very new technology, as we can say, as we can see the transition of IPv4 to IPv6 right now in the enterprise networks. So we will see a lot of things with the IPv6, and also we will see how we are going to make sure that this IPv6 is not this IPv4 is not basically used in the production environments, right? Like, can we rely on the IPv4, and what is basically the need of this upcoming IPv6? So everything we are going to talk about here in this webinar today. So without wasting any time, let's get started. So first of all, before starting this webinar for your IPv6, I'm going to give you some introduction and the webinar agendas as well, that what are the topics which we will be covering up in this webinar. So the first topic we will be looking into, we will have some IPv6 introduction. So in this IPv6 introduction, we will see what exactly this IPv6 address is and what is the need for IPv6 and why we are using this IPv6. Is it like the right time to use IPv6? So many questions with IPv6 are there in our mind, which we will clear in this webinar. So once we will clear the introduction to webinar, then we are going to see IPv6 versus IPv4. So here we are going to see the differences between IPv6 and IPv4, like how it is different from IPv4. And then once the differences are clear, we are going to look in more in detail about the types of IPv6 addresses. Now, when I say types of IPv6 addresses, so these addresses are here in IPv6, we do not have any specific class like in IPv4. We used to have some A, B, C, D, E class, but here we don't have any classes. Instead of that, we do have some address categories here. Then once after completing the IPv6 types of addresses, we are going to look into some configurations of IPv6. So we will configure some IPv6 with OSPF, and we will see one more new thing today, that OSPF version 3, which is only going to support the IPv6. So this is what we will do. And then after configuring the OSPF, I do have one more thing to share with all of you, that in uh, in IPv4 we do have some ARP resolutions. So here we do not have ARP resolutions, but here we do have something called Neighbor Discovery Protocol. So we will see this NDP as well with some practical verifications in the upcoming slides. So without wasting any time, so we can start with the webinar. So let's get started. So the webinar is all about IPv6, like how basically it is being transitioned from IPv4 to V6. So as we know that this IPv6 is basically a very advanced version of IP which was released after IPv4, right? So basically there are two versions of IP, we can say two versions of IP we do have. The first version of IP we do have is like IPv4, which we all know, and the second category we do have is your IPv6. So IPv4, we all know that this V4 is consist of 32 bits, whereas this V6 is consist of 128 bits. Now, whenever we are defining the bits, so after that there is one more thing, like this V4 address is always written in the decimal format, whereas we write this IPv6 in hexadecimal format. So this is some basic difference which we all know. But what is the main reason for IPv6? Like why we need this IPv6 now? Because we are still surviving on IPv4, as you are going to see that in most of the production environments today also, many companies are still relying on IPv4 address. But what's the need and what's the main reason besides using this IPv6? So we can say the main reason is the shortage or exhaustion of IPv4 address. So if you will see technically that in IPv4 address, there are 32 bits. So if you will go with 2 raised to power 32, so here you are going to get some 4.3 billion addresses in IPv4. So it is not relevant, like, which is not this 4.3 billion is something like the count which is not going to support the rapid growth of the growing network. Because like today we know that the population is increasing and we cannot survive on 4.3 billion addresses. And even though we can say in the productions as well, we are checking out that there is a very rapid growth of the networks in the production environments. So before introducing IPv6, like after IPv4 was launched, there were two solutions which were created or which were invented to make sure that we should not run out of the IPv4 address. So like net was introduced, network address translation, and subnetting was also introduced after IPv4. So these two solutions were introduced to make sure that we save IPv4, that will save IPv4 addresses. But somehow, like, 4.3 billion addresses after putting these two solutions, net or subnetting. So after that, we were also running out of the IP addresses. So after, like, these solutions were invented, there was something which was launched as IPv6 address. And this IPv6 was launched in 1999 in the month of June, and this IPv6 was announced in this 1999 in the month of June. And now these days it's pretty much mandatory for every of the operating system, like whatever the operating system which is coming in the market. So by default, like it is specified and it is mandatory for all the vendors who are creating operating systems. Like if you will talk about Microsoft, Cisco iOS, or whatever the operating systems are there which we are using in the market. So like it's very much mandatory that every of the operating system should be enabled with IPv6 feature. So if, like, it was pretty much mandatory that in today's scenario you will see that every device is going to support the IPv6 features. So we will be talking about some comparison between IPv4 and IPv6. So we can write it as a heading as, like, we can say advanced IPv6 features. So in this advanced IPv6 features, we have some points where we will be comparing this IPv6 address with this IPv4 address. Like what makes IPv6 better? So here we are going to see the first point, that in IPv6, as we know that this IPv6 is an extension of IP address with, like, several advanced feature we can say. So the first advanced feature in this IPv6 is that we always have large address space. Now, when I say large address space, so here I refers to, like, if you will see the previous slide, that here on the slide when I was mentioning this IPv4 was having 2 raised to power 32, which gives us 4.3 billion addresses. But with IPv6, if you will see that we do have some 2 raised to power 128. So technically, if you will see, like, we have some addresses in trillions, where, like, which is in trillions, where every person can survive with one single IP. Like, up to like 20, 30 years more, we cannot say that this IPv6 will be discarded. So up to 20, 30, 40 years, we can easily survive with this IPv6 address. So because we do have address space in trillions, so we can write the address space which we do have here is, like, it's in trillions, which I specifically meant by 2 raised to power 128. So this is what the large address space I was mentioning. And also we don't need network address translation. So we can say no need of network address translation in IPv6, and we can write this point up to now, because right now we are surviving on IPv4 also and we are using IPv6 also. But we cannot assure what is going to happen after 50 years. So it's not like, right now there is no need of net in IPv6 up to now, but for future we cannot say or we cannot commit. Then the third point we have is, like, there is no broadcast here. Like in IPv4, we have some broadcast techniques, we have some multicasting. So multicasting is there in IPv6 as well, but this IPv6 is not going to have any kind of broadcasting. And also it supports auto stateless configuration. So we say supports stateless auto configs. So when I say stateless auto configs, so this stateless auto configurations means like a device can get IPv6 address by including its own MAC address, which I'll explain you in the lab scenarios when we will perform the lab things. So this is one thing which we need to take care. But then after, we do have some other features, like we can say we have inbuilt security in IPv6. Now, when I mention the inbuilt security part, the only thing come to our mind is that we do have some IPsec here, and this IPsec is basically inbuilt inside the devices, which we all know. Now, when we are talking about the next feature, so here we can say that in IPv6 we do have the capability to have multiple addresses per interface, capable to have multiple interfaces, or we can say multiple IP addresses per interface. Now let me give you one example, but what basically this last point means here. So if you'll take one router, let's say we are having this router, and on this router we have this interface like let's say FA0 by 1. So over this FA0 by 1, let's say if you assign some IPv4 addresses 10.0.0.1, and like after assigning this IP, let's say you again write one command IP address 11.0.0.1. So technically it will be overwritten. Like then we will be getting some 11.0.0.1. But if you are going to add some secondary keyword here, then it will be possible to have two IPs on one single interface. But although it's not like recommended, but if you will go and figure it out in the IPv6 address, so you will find that in IPv6 we can add this kind of scenario like where we can have multiple addresses as per interface. So this is the first thing which we need to understand about the IPv6. And now like when we will go with the IPv6 configuration, so there is one more thing which we need to understand. And the thing is like, for example, if you are assigning two IP addresses in the IPv6, like let's say this is some IPv6 interface, so you can assign one public IP as well, or also you can assign private IP on one single interface. So this is what we can do in this IPv6. So this is what about like, just a little comparison about IPv4 and how it's different and how it's basically advanced in as comparison to your IPv4 v4 address. So this is what we have seen. Now let's have a look at some structure of IPv6 address, like how exactly the IPv6 address looks like. So now, whenever we are talking about the IPv6 address, so this IPv6 address is something like it is a 128-bit address. It's written in hexadecimal. So we can take one example to understand this entire structure of IPv6 address. So let's say we are going to write the heading as IPv6 structure. So when we talk about the structure of IPv6 in here, so basically, let's take one example that I'm going to write one IP address here. So I'm going to write, let's say 3001 colon 004A colon 0000 again colon 0000 colon, let's say 1 2 3 4, again we'll write some zeros, and again I'll write some zeros, and let's say 1 2 3 4. So this is a sample IPv6 address which I have written as of now, and this is 4. So basically, like this is the structure of IPv6. This is how the IPv6 address looks like. Now here, like it's by default a 128-bit address which we know and which is written in the hexadecimal, where each portion is going to represent 16 bits. So like if I'm going to mention that this 3001, let's say I'm going to write here 3001. So this 3001 is going to represent 16 bits in total. 16-bit means like this single digit here, this 3 is also representing 4 bits here. So in total we have 8 portion, and each portion is going to represent 16 bits, like one single number represent 4 bits in here. Now in IPv6, guys, there is some or more thing to understand. Like, IPv6 structure is also classified by different scenarios. Like you can say, this is divided into two parts. So we call the first 64 bits of IPv6 address as global prefix value. So just let me erase this one. So the first 16 bits are known as global prefix value, and the last 64 bits are considered as interface ID. So when I say global prefix value and when I say interface ID, so global prefix value is more similar to your network portion, and this interface ID is more similar to your host portion. So in brackets I'm mentioning it's your network portion and this is your host portion. Just to understand, we can understand like this, that in the IPv4 also we have seen that there is some host portion, there is some network portion. So in total we have 8 portion here, like you can see 8 octets we do have, and every octet is going to represent 16 bits. So we can say and write as well for a better idea that we have total 8 octets where every single digit is equals to, we can say, 4 bits. But this is something for your personal understanding to make sure you understand, but we're not gonna write this as of now. So let's try to see that how we can make this IPv6 address more shorter. Like as you can see, it's a 128-bit address, so it is also possible to make this address as shorter address. Now by default, these 64 bits are considered as global prefix values, and it's not recommend or mandatory that they should stay constant. We can change this global prefix value, but as of now there is no need to change, so we'll not do anything like that. But yeah, it can be changed, like we can change in the subnetting portions as well. So now we will see that we can make this IPv6 address more shorter by reducing the number of zeros here. So you can see that when I'm writing this IPv6 address, so I do have the first number given as 3001. Like this is my first octet colon colon, and here we have this 00. So when the zeros are on the left side, so you simply can ignore, you can simply write 4a. The IP will like the machine will automatically understand that there will be some two zeros here, like we can reduce these zeros. And if you will look this third portion and this fourth portion in here, so you will find that these three like this third portion and the fourth portion, we can make it more shorter by using one single zero, because we do have continuous zeros. And then again we will write 1 2 3 4, again colon 0 colon 00, and again 1 2 3 4. So this is the one way of writing the IPv6 address, and we have make it more shorter. As comparatively you can see it's pretty much short as of now. But if you are going to make it more shorter, that too is also possible. Let's say if you are going to write 301, 3001, 4a. Now you can see the third and fourth portion. You have continuous zeros here, like 8 bits are inside something, we can say 2 bytes or 2 octets are in 0. So instead of writing 00, we can write double colon, and then we will write 1 2 3 4. And here also we have this continuous 0. So if you will write this double colon like this, and you will write the IP, let's say 1 2 3 4. So this is an incorrect way. This is never going to be marked as a correct IP. So we are not going to do like this. So the correct one will be represented like 3001 colon colon 4a, again double colon 0, sorry, not 0. We are going to write double colon, and then we'll write 1 2 3 4 colon 0 colon 0, and then we'll write 1 2 3 4. So only you can use the double colon once at a time in the IPv6 address, because it is something going to represent that you are going to make two continue octets as in the similar values. So this double colon represents that you have continuous zeros, like which you can see in the third octet and here in the fourth octet. Or if you wanna use the double colon on this side as well, so you need to make sure that here you will write the IP address like this. So this is the continuous zeros, like as per the third fourth portion you can use double colons with the continuous zeros, and this is how the correct IP will look like. So this is how we are going to make it more shorter. Now once this is understood to everyone, now we will move to some address types here. Like we have some types of address in your IPv6 which we are going to see. Now in that address types we do have three categories which we will see. So let's move to the types of addresses as well. So when we are talking about the types of IPv6 address, we do have three categories. So let's say types of IPv6 addresses. So in the types of IPv6 addresses, if you are going to see that we have three categories. So the first category we have is your unicast. And the second we have is your multicast. And the third one we have is your anycast. So these are the three categories which we do have in your IPv6 addresses. Whereas when we will go more in detail, we will find that this unicast is consist of three more IP addresses. Like this unicast is of three types, which we will see. So just to simply define these three types of addresses, I'm going to write just a quick introduction that this unicast address, when we are talking about this unicast, so it is pretty much similar to the normal IPv6, which can be assigned on any device. So this is normal IPv6. This multicast is similar to D class, and this anycast address is it's similar to multicast, but it is different from broadcast, which we will see in the upcoming session. So now let's try to see the category wise. So the first category we have is your unicast address. So this unicast address, like when we are talking about this unicast address, this unicast is something we can say inside this unicast we got three categories. So we can write we got three categories of unicast address. Now, the first category in this unicast address we are going to get is your global unicast. Now, this global unicast, when we are talking about this global unicast, is something like we can say it is more like a public IP. So, like a public IP. When I say it's more like a public IP, so how you are going to identify that, is there any range, is there any specification, like in the IPv4 we can identify that this IP is basically belongs to A class, B class, C class. So here there is a range which is reserved by INA. So any address which is starting from 2000 colon slash 3. So any address which is starting from this range 2000 double colon slash 3 is considered as your global unicast address. Now here the slash 3 represents that the first three bits will always be 001 by INA. Now when I say 2000, let's say 2000 I have said here. So in this 2000, this 2 is consist of 4 bits. If you will go with the conversions, now every number represents 4 bits, so the complete portion is of 16 bits, right? So the conversion of 2 in binary, like if you are going to convert 2 into the binary, so it will look something like this. Let's say we'll write conversion of 2 in binary. So here this is how we'll convert 8421, because 4 bits are there. So the conversion is like 2, so it will be 0, 0 and 1, and it will be 0. So here you can see the first 3 bits are constant here. So 001 is constant. So as per our statement, like as I have written here, that this slash 3, so this slash 3 is like the situation where we are going to get this first 3 values as constant. But there can be a situation like if you will go and see 0, 0, 1, this is the constant portion. But here lastly we have some 0 as well. So there might be a chance or situation that we can get some 1 as well. So if we are getting this kind of scenario, the conversion we are getting is something like 0, 3. So basically this is the conversion for 2 and this is the conversion for 3. So by the first three bits you can see are constant 0, 0, 1 in both of the scenarios. So that's how you will identify that in simple, like if any portion in IPv6 address which is starting from number 2 or number 3, like either it is starting from 2 or 3, so that number will be considered as global unicast, which is defined by INA. So this is what your global unicast address is. Now coming to the second category of this unicast address. So the second category of this unicast address is your unique local. So we'll write unique local. Now when we are talking about this unique local, we can say it's more like a public IP, sorry, more like a private IP. The private IP, which we know that it can be assigned on any devices inside the LANs, and as per INA, the reservation which is done for this particular private IP is FC00::/7. So here the /7 means the 7 bits are constant. So we can say any address starting from FC or FD will be considered as unique local. Now why I say FC or FD? So you will see, like when you are going to do the conversion of FC, so FC00, and when we will be putting the conversion of this FC00, so you can see that here when we will be doing the conversions, so we'll write conversion so that you can understand. So in the conversion, when I'm going to convert F and C, so F is equals to, we know that it is 15 and C is equals to 12. So we got the conversion here 15 and 12. So now we will see the binary conversion of FC. So the conversion of FC will be something like, we will use the same again, 8421 and again 8421. Now when we are going to convert the value of 15, so we'll say 1111. So this is the conversion of F and this will be the conversion for C. So for C it will be 1100. So like the entire conversion of FC is equals to, you can see we have 1 1 1 1 4 times 1 and again 1100. So if you will see here, like this portion 4 5 6 and 7, so till this part, till this 0, this is the constant portion which is representing your /7 here, which we have written in here as well. So now if you will go with the equivalent value, so if you are going with some equivalent value, the conversion can be something like this as well, like 1111 1101. So in that case, you are going to get some scenario of FD if you will check the conversions. So this is what we have to say, that whenever any address is like starting from FC or FD when the IPv6, that means that is unique local and that address is considered as a private address. So this is what we have to understand about the global unicast and the unique local. So global unicast is your public address and this unique local is your private address. So in it's, they both relies in the category of unicast. So right now we are only talking about this unicast address, we are not on multicast or anycast. So we'll see this unicast. Now we'll go to the third category of this unicast, which is pretty much important. So we call the third category of the unicast address as link local. So this link local, when we are talking about, so this is something which is the default IPv6 address enabled on IPv6 interface. So let's say if you have assigned any IPv6 address to any interface, so in that case, this link local address will be there. So it always starts with the range of FE80::. colon colon, and then we are going to write /10, and rest remaining part will be the MAC address, and this thing I will explain you in the NDP process. Remaining is MAC. So we'll just skipping this part, link local to the lab scenarios where we will see. And this link local address is always represented in the local area network. It is not recognized outside the LAN area network. So this is the first thing. Now coming back to the second category, which was your multicast. So when we are talking about the category of multicast, so this multicast is more like D class. So it always starts with the range of FF00 colon colon /8. So here /8 bits are represented, and we can say more similar to D class. So this is what your multicast address is. And then lastly, the category which we have is your anycast. So when we are talking about this anycast address, this anycast is something, let's write here. This address is used to identify multiple interfaces, but it sends only to whichever it finds first. But sends to whichever it finds first. Now, what I mean by this statement is basically, let's say that you are using this computer, and in this with this computer you are connected to some internet service provider. Let's say this is your internet service provider, and like there are various servers of there are various public servers. Let's say you're browsing Facebook here. So these are multiple Facebook servers, or like these are multiple Facebook public servers which are over there on the internet. So like from the internet, like if you are accessing Facebook, so your packet will go via like this. When your packet will reach to the ISP, so then from reaching to the interface like of the ISP, it will check that we know that there is not one single server of Facebook over the entire world. So there are many multiple servers, and all these servers of all these public servers are internally connected with each other, right? So when these public servers are internally connected, and they maintain a copy of the information as well, and they are also linked together. So if you do have some knowledge of server, so in server we call this like a group of servers acting as single server. So like this term is considered as cluster, like where we have multiple servers, and there are like multiple servers which are interconnected with each other over the wide area network, so we call it as cluster. And to that cluster we are going to assign one virtual IP. So this virtual IP can be any cast address. It can be your global unicast, or it can be your unique local. So whenever the user is trying to access, so with the help of this anycast address, whichever the public server finds the packet first, it's going to reply the same to the public, to the particular PCA here and as well. So this is what your anycast address is referred to. That here, like we do have some concepts or scenarios you can manipulate, like some HSRP scenarios. So that can be used here as well, which we will see in the upcoming sessions of our trainings, which we will be doing in the Encore and CCNAs. But right now, this is just as of now an example to understand what exactly this anycast address is. So once you understand this anycast address, now let's try to summarize the addresses which we have discussed as of now. So we have discussed the three categories of IPv6 address. So just let me write down that again. So we have this IPv6 addresses. So in the IPv6 addresses, we have discussed three categories. The last one was your anycast, which we have discussed. The second was your multicast, and we have some unicast as well. So in this category of unicast, we have discussed that there were three categories. The first one was your global unicast. The second one was your unique local. And the third we have discussed was your link local. So this global unicast is more like public IP, and this unique local is more like your, we can say, the private IP, whereas this link local it is already enabled by default on the IPv6 enabled interfaces, which I'll show you practically as well. Now guys, as we are talking about the OSPF configurations, so let's try to see some lab things. So I'm going to share my screen and we are going to see some lab scenarios here. So as you can see, here is my lab screen and I have already pre-configured the topology. So as you can see right now, this NDP lab is something different which we will perform later on. So right now you need to focus on this topology which is there, which is your OSPF version 3. So in this OSPF version 3 lab, we are going to see that this VIOS 1 is here and this VIOS 2 is here. Now, when I say this VIOS 1 and VIOS 2 are interconnected with each other, but there is no IP address assigned on the interfaces. So first of all, we will go on the VIOS 1 and let's try to verify the configurations. So as of now, there is no configurations on the VIOS 1. So you can see R1, and if you will verify show IP interface brief. So you can see there is no IPv4 address, and if you will verify show IPv6 interface brief. So you can see that there is no address assigned as of now, neither on gig00 interface or nor on this gig01 interface. Now, when we will configure this thing, so we will let's try to see how to assign the IP addresses. So I'll go on the router one and I will say interface gig0 by 0, and over the gig00 interface I am going to configure some address which is mentioned here. So I'll say IPv6 address, and the address is 2001 colon 12 colon 12 colon 12 colon colon 1 slash 64. The slash 64 means that this is the subnet value, or we can say the global prefix. And once this is done, we'll simply say no shutdown, exit. So you will see the interface will come up. So you can see the interface is now up, and also on the router one, I'll select the interface gig0 by 1 and I will say IP address FC00 colon colon 11, or we will write IPv6 address here because we are assigning v6 colon colon 11 colon colon 11 colon 1 slash 64, and I'll say no shutdown. Now, once the IP configuration is done, we will verify the same thing in the command which is do show IPv6 interface brief. So here you can see that both of the interfaces are in the up state, and also you can see that we are getting some link local address as well, which is FE80 here and also FE80, and the remaining part of the MAC address is your base, the FE80, and remaining part of this IP is your MAC address, which you can also verify. Do show IPv6 interface gig0 by 0. So when you will verify the same thing, so we need to find the MAC address in here. So you can see this is the link local address which it is using as of now, and IPv6 is also enabled, and the global unicast address it is going to use, and it has also joined some groups which I will verify you. Now let's go to the router 2, and this is your router 2. So on the router 2, we need to configure some other configurations as well. So let's say configure terminal interface. We are going to select gig0 by 1, and over gig01 we will say IP address, or sorry, IPv6 address, and then we will write FC00 colon 12 colon 12 colon 12 colon colon 2 slash 64, and we'll say no shutdown, exit. Now we will assign the next interface which is gig0 by 0 with some IPv6 address 2001 colon 12 colon 12 colon 12 colon colon 2 slash 64, and I'll say no shutdown. So as I have written the no shutdown command, so you can see the interface is now in the up state. So once the interface is now in the up state, so when you are going to do, Now, the thing we need to do is the IP configurations we have already applied, and in OSPF version 3, we need to do something and we need to understand one more thing. So let's go on the router one and let's step by step verify the configurations of IPv6 OSPF. Like, IPv6 is like with OSPF version 3. So instead of running on the subnets, in IPv6, OSPF version 3 runs on the link. So here we don't need to advertise the network. We need to let the interfaces know that you are configured with some OSPF configurations. And now how to do that? So first of all, you need to run this command IPv6 unicast routing. So with this command, like you have enabled the routing on the IPv6, and then you need to write IPv6 router OSPF 1. So once you have written this command, then you need to define the router ID manually, because router ID in IPv6, it's something like it cannot pick automatically, and the router ID always needs to be assigned in the IPv4 address type. So we will say that router ID 1.1.1. So this is the router ID, and I'm simply going to say exit here. Now once this part is done, over the router 1, I'll advertise both of the interfaces. So as you can see, the interface gig 0 by 1 is basically a part of area 10. So I'll say IPv6 OSPF 1 and the area you are in, like area 10, exit. And again I do have the next interface, which is gig 0 by 0, and we will write IPv6 OSPF 1, and this is a part of your area 0. So once this part is done, now we need to simply exit, and we will be going to the next configurations, which is on your router 2, and the same configurations we need to execute here on the router 2, which we done on the router 1. Like first of all, we'll enable the IPv6 unicast routing. Once this command is enabled, we'll let the router know IPv6 router OSPF 1, and then now we need to assign the router ID. So let's say the router ID I'm assigning here is 2.2.2. Once this is done, simply exit, advertise the interface as, I'll say interface gig 0 by 1 IPv6 OSPF 1, and it's a part of area 0. Exit again, you will see interface gig 0 by 0 IPv6 OSPF1 area 0, and exit. So now we'll wait for the logs. So as you can see in the IPv6, we have configured the OSPF. Now if you will verify the configurations, so you can run the command show IPv6 protocols. So here you can see the current running version is OSPF version 1, and the router ID on the router 2 is 2.2.2. Number of areas is 1, and when you will see show IP V6 OSPF neighbor. So you can see we are also getting the neighbor as 1.1.1. So this is how we are going to configure the OSPF configurations. And if you want to verify show IPv6 route, so you can see that OSPF inter area is also there, like with some area of 110 in here, which is connected via gig Ethernet 0 by 0. So this is how we are going to configure the OSPF version 3. Now guys, this is what like basically just one example for your routing was. Now when we are talking about the next lab which we have discussed, which is your NDP. So when we are defining this neighbor discovery process in your like we can say IPv6, so it is pretty much similar to your ARP resolutions. So in IP address v6 we don't have address resolution protocol. So instead of using address resolution protocol, we are going to use this NDP here for finding the device MAC address, and in that neighbor discovery process, it is going to use two different types of messages. Like let's write the same on the PowerPoint about the NDP on IPv6. So in NDP in NDP in IPv6 here, this NDP means neighbor discovery protocol. Like it is similar to ARP, but here we have something different. So like it is going to use some two different types of messages here. NDP uses two different types of messages for resolving IP to MAC. The first message it is going to use is your neighbor solicitation message, which is NS, and the second is NA. So this NS means neighbor solicitation. So we can write neighbor solicitation, and this is your neighbor advertisement. So this solicitation message is something, it is a request for layer 2 address information. So we can say it is a request for L2 information, whereas this neighbor advertisement is the reply of the neighbor solicitation message. Now, if you are going to see how basically all these things are going to work, so if whenever this like as per the lab topology which we have created, so we will try to see this is the router 3 and 4. So when the router 3 wants to ping with the router 4, so first of all, like it is going to send a ICMP type 135 where it is going to say that the source IP address will be the IPv6 address of the device. So whatever the IPv6 you have executed here on this device will be there. And once the address is there, so the destination is going to use some solicit multicast node addresses, which is like, we can say that if the devices are in the same network segments, then they are going to join a specific group of addresses, like that address can be your multicast address, and this address is then known as your solicited node multicast address, which we can verify in the IPv6 interface as well. So now to verify all these configurations, let's try to see something like we'll go on this router 4 configurations. So this is your router 4 configs and nothing is there. So I'll simply write configure terminal hostname R4 and I'll assign some IPv6 address on this router 4. So let's say interface gig 0 by 0, and before that let me verify you show IPv6 address, sorry, show IPv6 interface brief. So you can see nothing has been assigned as of now, but now if you will go and configure some IP addresses, interface gig 0 by 0, on gig 0 by 0 you will say IPv6 address, and the address we are going to use is 2001 colon 12 colon 12 colon 12 colon 2 slash 64. This is the address we are going to use, and I'll say no shutdown exit. And when I'll done this part, I'll run one more debug command here for the better output verification. So let's say we are going to run command debug IPv6 neighbor discovery. So this is the command which we have enabled. Now all the neighbor discovery events will be there. So now let's go, and now you will see as per the default behavior when we will execute some IP address on the VIOS3. So there will be some neighbor solicitation messages. There will be some neighbor advertisement messages which will be generated on the next router. So let's say configure terminal interface. We have this gig 0 by 0. And on this gig 0 by 0, you're going to say IPv6 address, and the address we will execute is 2001 colon colon 12 colon 12 colon 12 colon 1 slash 64. So once we are going to press enter, there will be some logs which were generated over the next device, which is your router 4, and I'll say no shutdown. So let this port go in the upper state, and now when we will see the debug output on this VIOS 4, so we'll see some neighbor advertisements and neighbor solicitation messages. So you can see that here some packets were generated like for the neighbor discovery. So you can see it receives one neighbor advertisement from the link local address. So if you will verify like show, let me debug undebug first, and now if you will verify show IPv6 interface brief. So you can see that here the global link local address we are using is FE03 in the end. So here we are using FE04. So that means this FE03 which we are getting here, like we are getting a neighbor advertisement from the another router which is having this FE03. So you will go here on the router 3 and then you will verify show IPv6 interface brief. So you can see the link local address of this router is sending one neighbor advertisement message. So when the neighbor advertisement was sent, so it tried to capture and it received the neighbor advertisement, and then it proceeded with the resolution of the MAC address here as well. So basically with the help of this NDP protocol, like using this link local address, the devices are going to perform your basically this neighbor discovery processes, because it is something we can say that normally what happens is when you connect any new network segment, any new device to any new network segment, and then you are going to assign IP to any of the specific interface. It is like something, it can be link local or it can be on a normal IP. So it is always going to send a request on the same network, that in that request it is going to ask that is there any other node who is using the same IP. So let's say this device is using some FE03. So when the IP is assigned, this will generate one neighbor advertisement that anyone else is using the same IP or not. So once the message is generated, then the message will deliver to the router 4, and router will reply that no, I'm not using. Then in that case, the link local will be automatically considered, and then the link local is going to help us for this neighbor discovery process. So that is what we have discussed in the PowerPoint slide as well, that whenever we are configuring any IPv6 address, it is going to perform one duplicate address detection to the link local address. When the address is verified, that address is assigned to that particular interface. So that is what we have seen. And like this is what just a quick introduction for your neighbor discovery protocol. And there are various things in your IPv6 address, like we do have some router advertisements, we do have some router solicitation messages, we do have some like we can say a router advertisement card as well as a security feature. So as of now, as per the agenda, the things which we have discussed, so we started with some IPv6 introduction and we wrapped it up on the ARP process of IPv6 address. So basically the thing here, like what we have learned in this webinar, that the first thing, the types of IPv6 address. So let's just sum up the webinar. So we started with intro to IPv6. Then we discussed some types of IPv6 addresses. And also we just discussed the structure, how to make it short. Then after we just checked out some OSPF version 3 with IPv6. And then lastly, we saw some neighbor discovery process, which is going to use two types of messages, neighbor advertisement and neighbor solicitation. So this is what we have learned as of now. And also we have created one more blog for this neighbor discovery process in IPv6. So we'll definitely attach that blog link with this video. So for this webinar, guys, that is the end. And I hope every one of you find this webinar very useful. So that's all for this webinar, guys. Thank you everyone for joining, and I'll be waiting for you to answer your queries. So if you have any doubts, if you have any queries, so feel free to put your queries on the chat box so we can reply to your queries as well.